We're trying to connect, not to insult, I'm not insulting it, but I'm saying we are truly trying to connect dots here. This dot to that dot to that dot to that dot to that dot, but we're going to have some problems doing it because we have things in our way. So as I start drawing it to the right, I have this vertical barrier, right? I'm not allowed to cross a vertical barrier. These vertical barriers force my graph to do what? Either go up or down. Now, which way is it here? Up or down? Down? Why? Because it just looks like it's down?
Yeah.
Okay, why can it not be up? If I turn up, I'm going to cross the x-axis, and I can only touch the x-axis here. So it's not a flip of a coin, let me guess. It's actually a process of elimination. You cannot turn up because you create an x-intercept, therefore you must turn down. And when I say go down, it's just going to get closer and closer to that dotted line and never actually touch it, right? That dotted line continues forever. You remember last class we talked about this idea of getting closer and never getting there? We were talking about probability of getting hit by lightning and winning the lottery, right? That whole thing? Okay. All right, that's our picture so far. Got it? Now, I must, at this point, I must pick my pencil up and go to the next point that I see, which is this one, right? And I have to play the same game. Draw it to the left, draw it to the right. So to the left, what happens? Barrier right away, right? So that means I either turn up or I come down. If I come down, what happens? I hit the x-axis, right? So it's going to have to go up to the left. To the left, it's going to have to go up, right? What about to the right? As I try and draw it to the right, now you are truly in kindergarten. You're going to connect that dot to that dot, okay? There's nothing in the way, right, connecting those? And then you go from here where? To that dot. There's nothing in the way. Let me put those dots together first. Do you all see those three dots go together and there's nothing in the way? Right? The question is, out the left side of this dot, we either go up or down, but again, we can't go down because it can't hit the x-axis, so it has to go up. And then to the right, what happens? Barrier, up or down. Got to go down because you can't turn up and cross the x-axis, right? Looks like that. It's starting to turn into something now, right? And then we go to pick up our pencil, we go to our final dot. To the left, what happens? Barrier, right? Up or down? Up, right? Can't go down because you'll cross the x-axis. So you go up. And then final piece, you're going to draw it to the right. You see the magnet? It goes towards it. Gets pulled towards the magnet. And we have our graph. Okay, that took us 32 minutes or so. Yeah? So when in the real world are you ever going to graph a rational function? Never, right? Never, ever, ever, ever. Yeah, this is a certain part of your brain, right, that has to be able to execute this, right, to work through the procedure, not make any mistakes. So I'm going to go to Desmos, that graphing software, and I'm going to have the Desmos graph this for us. I'm going to have it graph f of x equals x plus 3 over x squared, plus 3x minus 4. And this is Desmos's version of the graph versus our version. I like ours. Right? All the characteristics that Desmos has, we have, right? As you go out to the left, we flatten out towards the x-axis. Right here between -4 and -4 and +2. Oh, wait, hold on. What the heck? Oh, it's 1. Sorry, I was looking wrong. Sorry, my vision from here didn't. It's +1. Let me zoom in a little bit. There we go. In fact, I can have, no, I'm not going to do it. I could have Desmos draw the vertical asymptotes, but See, remember, our vertical asymptotes are not part of our graph, right? They're there to help us draw it. If you take those out, then you have that picture, right? You take these green dotted things out, you get that picture. You satisfied? Like, does our graph look pretty close? Yes? Any questions? Yes?
So it doesn't have to be exact, the numbers that are going down when you put the...
Yeah, no. These don't have to be exact. These test points don't have to be exact because, again, that's a calculus class. In calculus, we actually get into the details of like how can we get more accurate pictures. All right. Gosh, you didn't realize you were going to be having this much fun on a Monday, did you? It is. No, that's the right word. It's the right word. Okay. All right. Let's do another one. That's the same function I just gave you, but I flipped it over. I did that to speed up the process here, so we don't have to go through and do a lot of the steps over, right? So let's do step 1. How do we find, what do we find for step 1? X-intercepts. How do we do that? Numerator to 0. So it's like the numerator and denominator have switched places, right? So this now is the numerator set equals 0. Since we've already done that, can I just go right to the answers without showing the work? Is that all right? Okay, the answers we got here were -4 and +1. What are these going to be on our graph? X and points on the x-axis, right? Okay, let's do step 2. Vertical asymptotes. Set the bottom to 0. One answer. One answer. Subtract 3 on both sides. Yep. Okay? Third step. Horizontal asymptotes. Okay, what's the degree of the numerator? Numerator, I'm just going to put num equals 2. Is that okay? I mean, the degree of the numerator is 2. What's the degree of the denominator? Is 1. 2 is bigger than 1, right? Yeah. So the numerator's degree is bigger than the denominator's degree this time. What case are we in over here? How are you going to remember these on the test? Yeah, you're not going to remember them. You're going to have them on your reference sheet, right? So you don't have to memorize these. You just have to have these on your reference sheet. So case B, right? Case B. And what was case B? Because I didn't put it there, but I did in the notes last time. No horizontal asymptote. You have no magnets here. Okay? There are no magnets on this graph. Nothing is pulling your graph towards it at the edges. All right. Fourth step. Fourth step, we draw it, right? And get our test points on step 5. So here's my drawing. All right, at -4 and at +1, I have x-intercepts. At -4 and at +1, I have x-intercepts, right? Those are where my verticals used to be, right, on the previous problem? Those are my verticals. Now they're my x-intercepts. We good? Is there a bad glare? No? Is there a real bad glare? Let me do this. You should have told me before. You just noticed it now that you're blind? Yeah. Does that help? That made it worse? No. Does that help? No. It's a projector itself? Okay, so it doesn't help anything. Yeah. Sorry. Yeah, don't stare into it for too long. All right.
Yeah, let's do this one.
Yeah.
I'm okay, but thank you.
Everyone's got sunglasses on now. All right, what else now? Do I draw vertical dotted lines here? No, right? These are x-intercepts, right? Okay, now the second thing I put on here, my verticals, now that's going to be a dotted. And that's going to be at -3. There we go. And we have no horizontals. So I'm not going to draw anything else. That's it. That's all the information I have. Questions? What comes next? Test points. Step 5. Test points. How many will I have? 4. How many x-intercepts do you have? 2. How many verticals do you have? So that's 3 total, so you should have 4 test points. You count how many x-intercepts you have, along with how many verticals you have. You add those together, and then you always add 1. So I have 2 x-intercepts, and then 1 vertical, that's a total of 3, and then add 1, I get 4. So I need 4 test points. Now let's find out where they are. Where shall we put these test points? Start at the far left. I have an x-intercept, right? Something on that side of it. We need something to the left of it. So something over here?
7.
What? I'm sorry?
-7.
-7. What did we use as a test point in the last example? Didn't we use can I use that again so we don't have to calculate it again? Okay. -6 here. And then we need something between these two again. So -3.5. We used that last time, right? And then this was 0. And then what do we use over here? It was 3, right? Okay, 3. That, right? So I'm using the same 4 test points so that maybe our life will be a little bit easier here. -6, -3.5, 0, and 3. Now, when I plug those numbers in, am I going to get the same answers or different answers than last time? They're different answers, but do they change signs? Or will they have the same sign? Remember, all we did was flipped it over, right? So if you take all your answers the way we got from last time and we flip them over, does it change whether or not it's positive or negative? Oops, sorry. Does it? No, it doesn't. What did we get when we plugged in -6? Someone go look at when we plugged in -6, what did we get? Like, was -3/14, right? Yeah. That's what we got last time, right? Now, we flipped the whole function over, so doesn't that just flip that over as well? And it's not that, it's actually -14/3. But it's still a negative number, right? Yeah. Still negative. It's a different number, but it's still negative. Which means all of my test points, look, this is the part that I'm just leaving this to you, okay? But I'm trying to get you to understand, like, if you did this, we're gonna get the same answers as we got from the previous problem. Wherever it was positive, it's positive. Wherever it's negative, it's negative. Now, they won't be the exact same position, but we don't care about position. So where was it over here? At -6, it was negative, right? Put a dot below. How about at -3.5? It was positive, right? Okay. And then at 0, wasn't it negative? I'm putting it down here. The only reason I'm putting it way down here is so it's not like hitting that, all right? I could have put it up here, doesn't matter. And then at 3, it was positive. There it is. Yes?
So before we had taken the quadratic and
Factored it.
When we plugged it in, that would still be a
Yes.
even if it's in your
Yep. Yeah, what you would be doing is doing this x plus 4x minus 1 over x plus 3. And then you start plugging your numbers in. If you're doing the short way, right? Go that, -6 in here. Let's just check it. -6 here would give you what? Negative. -6 here would give you, careful, -6 take away 1. Negative, so you have 2 negatives. And on the bottom, -6 in here would give you negative. So you have 2 negatives and a negative. These 2 negatives together is positive, so positive over negative is negative. So you get the negative when you plug in negative 6. All right, we good? Time to draw? Yes?
Space for a second. Where do we get the negative 6?
Our test point. We chose it. Just any point to the left of negative 4. We could have picked negative 7, negative 5. It's time to draw. So I go to my first point, furthest point to the left, which is this one. And I need to draw out this way. Tell me what happens. As I draw it this way, can it go up and turn like that? No, why? Why can't it go up? It'll cross the x-axis, so I can't have that. Does it flatten out and magnetically get close to something? No. Which means there's only one other option, to go down. So it's like this left side acts like a polynomial, like one of those, and you just have to figure out which it is. It can't be this because you can't turn up and hit the x-axis, so it has to be down. So I'm not going to draw it yet, I'm just thinking about this. It's going to go down here, right, like this. And then from here, I connect this dot to that dot, don't I? So it's going to look like this. Down, connect, connect. And then when I get here and try and draw it to the right, what happens? The barrier, right? Forces me up. Like that. Pick up my pen. Go to the next dot that I see, which is this one. And let me do this first. I see these three connect together, right? Any ideas of what happens to the right? It just continues up, or does it continue flat, or does it turn back? What do you think? It's got to go up, right? Why can't it turn back? Can't cross the x-axis. Why doesn't it flatten out? Because we said there's no horizontal, right? No magnet. So that means it must go up, so it turns up. The arrow implies that that just keeps going up. I'm almost done. There's one more thing I haven't done, which is this point this way. But what happens if I try and draw this way? The barrier, right, forces me to go up or down. And again, it can't go up because it can't cross the x-axis, so it has to go down. So I'm just going to connect these all together nice and smooth like this. That's the graph. Is this kind of making sense? What happens if you factor wrong? Everything's wrong, right? Like everything's going to be off. If you get like one of these points in the wrong position, everything's off. So we want to be meticulous about this. All right, let's see if we can do one more example. Any questions? All right, what I'd like to do here, I'm going to put it on the board. I want to see if you can work together in groups to at least try and get the first 2 steps of it done, all right? The first 2 steps. So it's going to be, let me see, our function's going to be, let's go with 3x squared minus, what do I want here? 27 over x squared. Sorry, I just want this to work a certain way. There we go. All right, I'm gonna go get a drink. I'll be right back. I forgot my drink today. So I'm gonna go grab a drink real quick, and then I want you to see if you can get at least the first 2 steps of this done. All right? Together, you can help each other out, talk. I'll be right back. I'm going to start working this out silently up here so you can look up and see if you're getting it. You should only have 5 test points. Yeah, where do your x-intercepts? How many x-intercepts do you have? How many verticals?
2.
So add 1 to that. Oh, you don't count the horizontal. It's only the verticals and x-intercepts. The horizontal you don't count. Yeah. Is anybody having any trouble with the step 1 or step 2? What's up? Step 1? Step 1, you set the top equal to 0, right? And then you try and solve this. So now we go back to how do we solve this? Well, first thing, try factoring it. GCF first. GCF never goes away, right? What number goes into both of these? 3, right? So pull a 3 out of there. Pull a 3 out of there. And when you pull a 3 out of that, you're left with x squared. When you pull a 3 out of this or divide by 3, you get 9, right? And then this you have to recognize as that very special difference of squares, which breaks down to be those two. Does that make sense?
Yes, I got the same answer as you, but I did it.
Did you move the 27 over, divide by 3, and then take the square root?
Yep.
That's okay too. Did you get 2 answers though?
Yeah.
Okay, then that's okay. You just don't have a factored version, but you have the same 2 answers. So that's okay. The drawback to that is that when you go to test your points, you're not going to be able to use a shortcut method because you never factored the top. Any other questions? No, you all right? Verticals? How about the vertical? No?
What happens when the horizontal is the same?
Okay, yeah, so why don't I do this? Hey, if we could just time out real quick, what I'm going to do is I'm going to just explain the horizontals real fast, and then once I do that, let's get our test points, and I'm going to let you try and plug in your test points and draw it, and then I'll tell you what it looks like at the very end, okay? So to do the horizontals, we look at the degree of the numerator and the degree of the denominator, and notice that they're equal, right? Those are the same degrees. So the numerator degree equals the denominator's degree, and that's case C. And this is the weird case. Whenever they're the same, then your horizontal asymptote is y equals And then what is it?
These
The leading coefficient. The leading coefficient of the numerator. That means you go here and you look at the number in front of it, which was a 3. And then you look at the denominator, you look at the number in front of that x squared, which is 1. And you take that 3, whatever number's in front on the leading coefficient up here, and you divide it by this leading coefficient. So 3 over 1 is 3. That is your horizontal asymptote. Y equals 3. Yeah?
I don't know why I made that face, but it was.
Questions? Let's draw a picture to get us started here. All right, x-intercepts. I have 2 of them. I'm going to do these as blue dots. 3 and negative 3. 3, negative 3, dots. Vertical. 2 of them, right? At 1 and at 6. One and 6. And lastly, our horizontal asymptote y equals 3. So up 3 units on the y-axis. So I'm going to go up 1, 2, 3. There's 3. And I'm going to draw a dotted line all the way through, right? Just like my instructor told me not to do, right? Now, I'm going to do it just at the edges, right? So up here at y equals 3, just at the edges, there's my magnet. And then over here as well. Understand? Got it all? 2 x-intercepts, 2 verticals, 1 horizontal. Question? Yes?
for the horizontal, when you draw at the edges, it means that it's points in the, so if any points that's in the y axis, you can draw.
Yeah, I can, my graph can go up here and down and do anything it wants to in here. All I know is when I draw it at the edges, I better magnetically like get close to that, okay? Either like this or like this. It doesn't matter. I just need to get pulled towards that magnet at the edges only.
So let's say, for example, negative 3 and point, there's a point on 3 on the y-axis? On the y-axis.
Yeah? What if there was a point up here at 3?
No, 0 to,
Oh, 0, 3. That's okay.
there's a point and you connect it.
Yeah, it's okay. Yep. Yeah, so if you go to the tutoring lab, I almost guarantee most tutors are going to draw the dotted line all the way across, and it's very confusing because it makes you think you can't cross it. Horizontal asymptotes tell you nothing about what's happening in the middle of the graph, only the edges. So that's why I'm not drawing it in here, because I don't want it to confuse you. So just draw it out here and out here. Now verticals are different. Verticals, you can't cross them, ever, right? So if I come over here, I have to go up or down. I can't just go up and over and down. You know what I mean? Like you have to treat those as barriers. All right. How about test points? How many are we going to have? 5. You count the number of x-intercepts and verticals. You do not count horizontals. So we have 1, 2, 3, 4. So I should have 5 test points. Five test points. This is that was step 4. Step 5, test points. I need 5 of them. Okay, can somebody give me the first one? What do you want your first test point to be? Negative what? Negative 4? Negative 4. So see that x-intercept? We're going to pick something over here. Negative 4? Good, that's 1. Give me the next one. Negative 2? That's Right here. What do y'all think? -2? That good? Could we have picked -1? Could we have picked 0? Yes. Okay, anything. -2 was requested. Okay, next one. 2. You should pick something between this one and this one. 2. And then, next one. 4. You could have